And the first thing we'll be taking is periodic table. So, or let me say, the module we'll be taking is periodic table. Under this periodic table, we have 7 modules there. So we have introduction to periodic table itself. We have the modern periodic table. After that, we have the electronic configuration, and then we have the trends. So they take them one by one. Ionization energy, atomic radius, electron affinity, and electronegativity. So we have about 7 modules. I don't know if it seems like it's something that's very simple. I can cover them in less than 30 minutes. But I think there are some parts since I saw the way the questions came today, we shouldn't summarize too much. We shouldn't summarize too much. Let you know my mistake. Let me know my mistake. So, since that's the case, we'll take the first thing. The first thing we'll be talking about here is about the periodic table. We all know what the periodic table is, at least. So, normally, after elements are being discovered, several elements are becoming much in existence. So scientists doesn't have choice, or they didn't have choice than to what find a way to organize these elements. How are we going to arrange them? The first person that worked with this was Antoine Lavoisier. Antoine Lavoisier divided elements. So let's be noting them now. Antoine Lavoisier. So it was the one that grouped elements into metals, non-metals, and metalloids. That was the first step taken on grouping of the elements. The first step taken towards periodic table by Antoine Lavoisier. He grouped elements into metals, non-metals, and metalloids. So after his own time, some scientists also came. We have the A. Decancoteur. If you have the course material with you, his name is there. Adechancoutois. That's his name. A. Decancoteur. He also made some contributions to the discovery of to the arrangement of elements in the periodic table. Actually, it's not what we're using these days now. So, but he made his own contribution. So after him, we have the J.W. Dobrina. We have Dobrina too. He did his own work. So Dobrina used the form of triads. Triads. So what we mean by the triad? They call them the Dobrina. Dobrina was trying to say if 3 elements exist, you should be noting those parts I'm addressing more on. Those are parts that we probably might have questions from. I kind of get what I'm talking about here. So when any part I buttress on, I kind of have some idea about the way it's going to, maybe the questions are going to come out from that place due to what I saw today. So Dobrina's triad is just about 3 elements. You said triad. So 3 elements being arranged. It might be column or row. So these 3 elements now we have the same, even colon to be precise. We have the same properties. So now the element that is at the middle, what Dobrina, JW Dobrina, what is telling us is that these 3 elements, he said potassium, lithium, potassium, sodium, and lithium, that if we add the weight of potassium and the weight of lithium together, we divide them by 2, we are going to get approximately the weight of sodium. That is that's what Dobrina said. So that's the case of weight. So if we now chemical properties, their properties now, the average of their properties will be the properties of sodium because it's at the middle. That is Dobrina's triad. It takes 3 elements like that, 3 elements like that, 3 elements like that. Beryllium, magnesium, calcium, potassium, lithium, sodium. So after Dobrina's own, we also have another scientist that worked towards it. That was John Newland. John Newland. So John Newland is also a scientist that is into music. He was into music and he was a great scientist, a chemist to be precise. So he actually did his own contributions too. He arranged elements. He said when elements are being arranged row by row, that is after each other, in 8, so now row by row, like first element like this, second element to the 8th element. So the next element that's going to start, we have, okay, when it gets to 8th element, it's going to have the same property with the first thing. So he now mentioned something. He said the way the musical notes, the 8 musical notes are always similar to each other. So that's one thing. So his own law was, or he stated the law, that's Octave's law. Octave's law in music too. So he called it the Octaves law. So that law was being rejected. Why? Because this man, John Newland, was trying to say that there is a mystical connection between music and chemistry, which many scientists believe is wrong. That's the first thing. Second thing is that it didn't even stand right. That law didn't stand correct for elements with higher atomic masses. So that's for John Newland. After John Newland, we have Lodamia. Lodamia, okay, Lothar. Loda, yeah. Lodamia, oh my God, I think I've made a mistake in the spelling. Lodamia actually did his own research too, and he made his own contribution. So he used, please, let's be noting this part. Any part I'm buttressing on, let's be noting them. I didn't mention some scientists, I didn't mention their contribution because I know some scientists might actually not come from this place. So this Lodamia, he did his own contribution. He did his own periodic table. He drew it out just by using the physical properties, plotting the physical properties against the atomic mass. He plotted the atomic volume against the atomic mass. Also, he plotted the boiling point against the atomic mass. So he got some elements, some graphs like this, where this thing determines the periodicity, the periodic banner, where this thing determines the reactivity of those elements there, where this point determine the reactivity. So the one that is at the top now means a very reactive metal element, let's say sodium. The one that is at the down means a very, very less reactive metal element. So let's say neon, something like this. So this was done by Lodamia. He used the physical properties like the boiling point, atomic volume, I think density, and the likes. So after everything, he worked in his own laboratory the same time the last person did his work. The last person who brought what we are doing today, using today as a periodic table, is known as Dmitry Mendeleev. I think 18 something to 1907 or something. Dmitry Mendeleev, a very common man. If we've passed through chemistry class before, even in secondary school, you should know, at least it should sound familiar. Dmitry Mendeleev, that's his name. So he actually did his own way thing by using the chemical properties like the valence. What is the valence of that atom? The way the atom can form hydrides and it form chlorides, oxides. So he did his own with chemical properties. That's a big difference between Logamia's work and Mendeleev's work. That's the only difference. Please note it. I'm quite sure that's part of our question. Dmitry Mendeleev did his own with chemical properties, while Lodamia did his own with physical properties. So now, Dmitry Mendeleev calculated these things, he made his postulate, and he was able to come up with this way, this method of arranging elements. He arranged elements into table. So he stated the periodic law, Mendeleev periodic law. So he said the properties of elements, that's the Mendeleev periodic law. He stated that law first. He said the properties of elements are a periodic function of their atomic weight. He arranged elements in the periodic table due to their atomic weight. Due to the atomic weight, that means atomic mass number. He arranged elements in the periodic table due to their atomic weight. That's from Mendeleev. So after he did, so he arranged all of them. He had some, but due to some anomalies in his own arrangement, after something was being discovered by Henry Moseley, we call that in the atomic number. Henry Moseley determined the atomic number, he discovered it, and he made an assumption that the atomic number is more fundamental in knowing the properties of an element than the mass number. So that made it easy for this man to come back around 1907 or something, Mendeleev himself. So because the first table he didn't provide space for the rare gases, the noble gases. all those neon, argon, krypton, xenon, all those less reactive gases, elements that don't react in the periodic table. Group 8 elements, it didn't provide space for them in the first periodic table it drew. Number two was that Mendeleev did not he did not put this thing that we call, what's it called? Hydrogen. He doesn't know where to put hydrogen in the periodic table because hydrogen actually has the properties of group 7 elements, but it has just one electron in its shell. So which makes it possible to be put in the group 1. We're going to explain all this. So now, someone raised her hand now. Okay. She actually disturbed me. She's distracted me. So now that is for the hydrogen. They also couldn't locate the place for the inner transition metals, even the transition metals themselves. So that's actually what the man couldn't do from the periodic table. So after the discovery of atomic number by Henry Moseley, so it became easy for him to do what he can do. So now he came with the periodic law again. He now said the properties of an element are a periodic function of its atomic number. So he arranged the elements in the periodic table due to their atomic number. Due to their atomic number. Like first element is atomic number of 1, second element, atomic number of 2, third element, atomic number of 3, fourth element, atomic number of 4, fifth element, atomic number of 5. The 100th element in the periodic table will have the atomic number of. What is the logic? Atomic number just means the serial number, to be sincere. No, it is more than that, a lot and a lot more than that. Let me just call it the serial number for us to make it in a lay way. It's a lot more than that, but let me just call it the serial number. So an element with 20, with atomic number of 20 is the 20th element in the periodic table. Hydrogen 1, helium 2, lithium 3, 4, beryllium. So like that, like that, like that. So I want you to know one thing also, that when this man called Dimitri Mendeleev developed his own periodic table, there are several questions that will be brought from his development. There were spaces because there were just few elements discovered, not just too few, but there were some elements that weren't discovered then. So this man had to lead their gaps. He predicted their properties and said, so this element is going to fit here. The element is going to have these properties, have these properties, have these properties, and after it's been discovered to fit here, to fit into this place, he left those gaps. So, and after calculations were being made, so scientists discovered elements and they actually have exactly the same predictions the guy has made, the man made. So, like the elements, I think gallium, aluminium, something. So I think gallium was the element. So a man discovered the element and he said he got the density to be 4.9 times 10 raised to power minus 9 kilogram per meter cube or something. So, and what's it called? Mendeleev predicted the density to be 5.9. So this guy came to Mendeleev, he said this, all other things correlate, they are concordant, but except this density. So Mendeleev had to tell him to go back to his calculation. Definitely he's wrong. So after he did the calculation again, he discovered Mendeleev was so precise with his own predictions. So he had to get what Mendeleev has predicted. So Mendeleev actually gave everything out. He's the best in that part. He gave the periodic law. So I say again, that the modern periodic law states that the properties of an element are a periodic function, or properties of elements are a periodic function of their atomic number. That is the modern periodic law. It's not the Mendeleev periodic law. The Mendeleev periodic law is the first one proposed by him. The next one was proposed by him too, and that's what it means, that he used the atomic number again. He didn't use the mass number anymore. So please, any question on this first? Any question, please? I have to be fast. It's because of my battery. My phone should be close to 20% now. And I think to start. Sure, trust me. Sure, trust me. I'm going to draw. Look at how I did my book. You know I wanted to draw the periodic table. You see, I'm not doing it. I've actually prepared for it. I've actually prepared for the periodic table. So here, this is the periodic table now. I will implore everybody. The exam is still about 5 days to come. Please, even if just because of the exam, try to know the first 30 elements at least. Hey, people have a lot of things thinking. Maybe just to know the first 20 elements and know how to make the periodic table. That's what will help. I'm going to use the periodic table now to explain almost everything I'm going to explain. So you guys should take a good look at the way I'm going to be. I'm going to my hand. So I have the first element here, which is hydrogen. So this is going to contain it. I have to make it contain it. So hydrogen, I have its second thing here, helium. Is it covering everything like this? So I still have here. I'm going to explain what we mean by the period and the group with this now. We still have this. Okay. So I think that one starts from the third period. Hydrogen, helium, lithium, beryllium, boron, carbon. Oh, beryllium. Hydrogen, helium, lithium, beryllium. So I'm going to come here for boron, carbon, nitrogen, oxygen, fluorine, neon will be here. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. After neon, I have sodium, magnesium, aluminium, phosphorus, silicon, sulfur, chlorine, argon. So after that, I should have where the transition metal comes in. Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron. After manganese, manganese, something before, okay. Is it cobalt? Iron, cobalt, zinc, copper, and zinc. This thing I'm drawing, I should have measured it well. Oh my God. Oh, manganese, nickel. Okay, let me redraw. I'll measure it well. The space I'm leaving now is not more enough for it. That's why I have to redraw. So so I said the thing is this is period. Let me be taking everything like that. So period comes down like this. Group rather. Group comes down like this. So this means this is group one. Group one. Group comes down like this. This is group one. The next one that comes after it will be group two. This is group two. So this is group two. So now this one is period one. That is row. The column means group. Why the period, the row means period. So I'm coming here to come and establish this. So I have hydrogen, helium should be here. Let me count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 is okay for those transition elements. So I think I have 6 more here. Don't worry, just take a good look at the way it comes and also try to understand the concept. This is group 3 then. So this is group 4. This is group 5. This is group 6. This is group 7. This is group 8. So now the group 8. So it's starting from where hydrogen start from. This is hydrogen. The first element in group 8 is helium. So I want you to know how to draw this thing. So lithium, beryllium, boron, carbon, nitrogen. Please mute your mic. I don't know the person that you're muting is on mic. Boron, carbon, nitrogen, oxygen. Mute your mic. Fluorine, neon, neon, sodium, magnesium. So you can see I'm not including the transition metal. In the first period, no transition metal. Second period, no transition metal. Third period, no transition metal. So the transition metal started from the fourth period. This is first period, second period, no transition metal. Third period, no transition metal. So fourth period is going to contain the transition metal now. So magnesium, aluminium, you can see it's just pore space, just a space for that place. Nothing is there. After my magnesium, I jump to aluminium, silicon, aluminium. After aluminium, uh, I beg tell me, aluminium, aluminium 13, phosphorus, abi silicon, phosphorus, silicon, for silicon 15. Hey, I don't confuse. Oh, okay. Silicon is 14. Phosphorus is 15. So silicon,
After aluminium,
phosphorus,
silicon, phosphorus,
sulfur,
sulfur, sulfur,
fluorine,
chlorine,
argon, potassium,
Potassium,
calcium. So after the calcium, scandium, titanium, vanadium, chromium, nickel, chromium,
cobalt,
manganese, iron, nickel, okay, nickel, iron, cobalt, copper, and zinc. So I think I have gallium here. I don't know these ones. I only know it to 30. I don't know to 36. But it should be something like gallium, selenium, krypton is there. So just don't let me give false information at this point. So these are the things me I know. So these elements now, this is what I'm going to use to now left. So the hydrogen is in group one because it is in the porous period. Hydrogen is in group one. So beryllium, magnesium, calcium, they are in group two. They are in group two. This is boron. This is aluminium. They are in group three. This is carbon. This is silicon. They are in group four. This is nitrogen. This is phosphorus. They are in, okay, after silicon, it is germanium. Trying to remember small. This one is gallium. This one under phosphorus is selenium. So group five, so nitrogen, phosphorus, selenium, they are under the same group. So group six, I have oxygen there, sulfur is there. I don't remember that. So fluorine,
Ali, Ali,
chlorine,
Ali,
yeah,
Ali. Under
yeah.
nitrogen and phosphorus, it is arsenic.
Arsenic, oh my God. Okay. Selenium will be under six then. Okay, do you have the table? Please kindly tell me. Let me fill this one up. Thank you.
Selenium under sulfur,
And I stand fine.
chlorum,
So
bromine under
and Python.
bromine.
Thank you for that.
Wait,
Thank you for that. Someone raised their hand. What's the issue, Miss Precious? Thank you very much, Mr. Yusuf. Miss Precious. Okay. Just don't raise your hand unnecessarily. That thing will be distracting, please. Hey, 15%. Okay. So now, as we're saying, the group 3 contains the boron, aluminium, gallium. Group 4 contains the carbon, silicon, germanium. Group 5 consists of the nitrogen, phosphorus, arsenic. Group 6 consists of the oxygen, sulfur, selenium. Group 7 consists of the fluorine, chlorine, bromine. Group 8 consists of the neon, argon, krypton with helium too at the top. So period 1 consists of hydrogen and only helium. Note that thing. I think I've saw the question. I've seen the question before in mock or something. So hydrogen and helium are in the first period. So the first period consists of only two elements. The second period consists of 8 elements. That is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. The third period consists of 8 elements also. So these ones now we call them 1A. This is 2, 1B, or what do we call it? 2A, 1B. Mm, One, okay. We use the Roman numerals to represent these ones. Three, I'll name them for you, don't worry. V, VI, VII, VIIIIX, and X. So that's what we use to represent these elements inside this place. We don't just call them in group 3 or group. So now group period 3 consists of sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So period 4, fourth period, in which the thing starts from the transition elements. They start from period 4. So it consists of 18 elements. Period 4 consists of 18 elements. Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, nickel, iron, cobalt, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton are all in the fourth period. So it keeps coming that way. It keeps coming that way. 18, 18, until you get to period 6. So period 6 and period 7, they contain 32 elements. So in the second period, second group and the third group, we have those things we call the lanthanides and the actinides. So I'm going to explain everything now. Please, I don't know if you have your book, just jot things down. Group 1 element. Group 1 element. That means all the elements in this group, they are known as the alkaline metals, alkali elements or alkali metals, the group 1 element. That means hydrogen. If you at least just know how to draw this thing, know the elements and know how to draw them. Hydrogen, lithium, sodium, potassium. You've known 4 elements from the first group. So why are they in the same group? Please know it. It is because they have the same valence, number of valence electron. What do we mean by the valence electron? Please look at it. I'm going to draw the shell configuration now. The shell configuration of hydrogen is 1. Valence 1. So draw the third shell. This is the K shell, L shell, M shell. So the third shell consists of just an electron. The next one is the potassium. I 1, 2. Potassium has the atomic number of 19. So 1, 2, 3, 4. So we are going to fill this one to 8. 1, 2, 1, 2, 1, 2, 1, 2. This is 8 now. It means 10. We are going to 19. Fill the next one, which is also 8. 8. We have 18 now. It remains just one in the outermost shell. So take a good look at this thing now. Hydrogen has one in its outermost shell. Hydrogen. Helium has one. Lithium has one in its outermost shell. Sodium has one in its outermost shell, and potassium has one in its outermost shell. That's why they are in the same group, and that group is group 1 because they have one valence electron. These are common questions. So elements are in the same group because they have the same valence electrons. Elements are in the same group because they have the same number of valence electrons. Who is raising their hand, please? Or who are raising their hands?
Okay,
Any
what I
issue?
wanted to ask is what you just said now. The valence is the number of shell electrons they have in their outermost shell, and it's the same thing as the number of their number of group, right?
Number of mole. Thank you, Mr. K. What do you say? Sorry.
No, I said the valence is the number of shell, the number of electrons they have in their outermost shell, and the number is
Yes,
the same
yes,
as the group they are in, right?
exactly, exactly. To some extent, to some extent. So we are going to explain why it's not to some extent. Just a few difference. We're going to explain. It's not right for oxygen. Okay. So that's for group one. I think we understand this one now. Please, who is this person sharing our screen? I think it's going to disturb me myself. Sorry. Thank you. Okay. So the all the things like that, beryllium to magnesium and calcium, they have the same number of valence electron. So that number of valence electron determines what group they are going to be, and that is actually why they have the same chemical properties. Elements in the same groups have the same chemical properties. Elements in the same group have the same chemical properties. Let's note that because they have the same number of valence electrons. So hydrogen to this, beryllium to this, and all others like that, they have the same chemical properties. So we are talking about the first group first. So they are known as the alkali metals. Number one, they are univalent because they have one valence electron. Univalent. One thing I haven't mentioned, elements in the same group have the same valence electrons, while elements in the same period have the same number of shells. Note that too. This is the first period. Yeah, and I have helium there in the first period. So they will have the same number of shells. Since they are in the first period, that means they will have just one shell each. Hydrogen has just a shell. This is only K shell. If I do helium 2, it has the atomic number of 2. Helium. So this is also one shell for helium 2. So in the same period, they will have the same number of shells. In the same group, they will have the same number of valence electron in the outermost shell. Valence electron. So that is one thing also. Note that, please. Okay, that's for that. As per that, alkali metals, they are all metals in group one. They are all metals except hydrogen that adds weight somehow. So, so actually is univalent too. So, but due to some things, it might go and be forming hydride with all these things to act as a non-metal. It also acts as metal sometimes too. So that is hydrogen. So the next place, the alkali metals, I'm thinking of some other properties. They are all metals. They are all solids. So they react, they burn in oxygen, like sodium. They burn in oxygen. I'm not talking about hydrogen again. They burn in oxygen to give peroxide. I think part of the questions I saw today, they even told me to write in formula. They didn't ask me to write it in name. They said write the formula for sodium peroxide. So I wrote Na2O2. That is peroxide. So all the elements in group one, they form peroxide. If it is potassium peroxide, it will be K2O2. If it is hydrogen peroxide, it will be H2O2. This is a very good reducing agent and a very good oxidizing agent. It works as both. H2O2. So we also have K2O2, Na2O2, Li2O2. So that thing, those elements in first group, they form peroxides. So they also react with water violently, very violently. They burn in oxygen explosively too. So going to the group two elements, they are known as the alkaline earth metals. Alkaline or earth metals. Alkaline earth metals. Alka, alkaline earth metals. They are group two. They are bivalent because they have two electrons in their outermost shell. So they react with cold water. I think they react with cold water, and some of them also form peroxide. So it will be CaO2, CaO2. I think yeah. So calcium peroxide. So after that, we are going to the third group. That is group of boron aluminum. They have few difference in them. Aluminum is a metal. Why boron is a metalloid? Boron is a metalloid. So group four, carbon is a non-metal. Silicon, so boron family, they call group 3 boron family. Group 4, carbon is a non-metal, silicon is a metalloid. So that is silicon is sand. It is very present in sand, very much in sand. Trioxosilicate salt. So trioxosilicate is very much in sand. So group 5 is nitrogen family. They are non-metals. And group 6 is oxygen family. Oxygen family are also non-metals. They are divalent. What do we mean by divalent? They are needing two electrons in the outermost shell. They are non-metals. All of them are non-metals in that place. So when an element is non-metal, it will be needing electron in its outermost shell. But when it is a metal, it won't be needing electron in its outermost shell. It will be giving out the electron it has in its outermost shell. All this lithium, we are going to donate that one out because they are metals. But all these ones that are here, see, let me give you the trend. These ones are metal. This thing like this. Look at what I'm drawing, please. Take a good look. This thing like this. It comes, this is the boundary between metals and non-metals. So boron, silicon, arsenic, they are metalloid. So from this place, aluminium, gallium, all these place, they are metals. All other ones are non-metals, except the neon and the krypton, all the group 8 elements. So now, group 7 elements are known as the halogens. Group 7 elements, they are known as the halogens. They are just the opposite of group 1 elements. Halogens. So they are univalent. They are very, very electronegative. They are very strong non-metals. So, and the group 8 elements are known as the noble gases. We call them the noble gas. We call them the rare gas. You know, they don't react anyhow. We call them stable elements too, because they don't react anyhow. They don't react with elements. They don't react with other elements. They are just on their own. They don't react with other elements. Though I've seen a compound like that, xenon fluoride, XeN4. They said they are using it in some light or something. So it's not that they don't react at all. They just react very, very rarely. That's why they call them rare metals, rare elements rather, rare elements, or noble gases, rare gases, stable elements. So rare gas. So I've seen a compound like this, xenon fluoride. So that's that as per that on periodic table and how it comes. So I've actually explained the structure of the periodic table now, and this is the periodic table given by the modern periodic law. What Mendeleev actually came to modify. He modified his periodic table. He gave space for the transition element. He gave space for the neon and the likes. He placed hydrogen in the right space, and he gave space for the inner transition elements. So talking about their way of configuration, the elements in this place, we call them S block elements, group 1 and 2. We call them the S block elements, group 1 and 2. We call them S block elements. Group 6 to 8, we call them P block elements. P block elements. Electronic configuration is another topic we'll be treating. So we call them P block elements. And group the transition elements, we call them D block elements. Please be noting that. Group 1 and 2, we call them S block elements. Group 3 to group 8, we call them P block elements. Group the transition metal, we call them D block element, and the rare earth metals that are inside this place, they start with actinide. The first row is for start with actinide, and the next one are artificial elements. They start with lanthanides, actinium and lactinum. That's lanthanum, actinium and lanthanum. So these ones, the two of them are known as the F block element. F block element. The thing that contains them, the row that consists of them, contains 32 elements. What do you have to say, please? You raise your hand.
Please,
You
you're
raise
a
your
little
hand.
bit fast. Can you slow down a little bit?
And I slow down.
Yeah, like you're talking very fast.
Ah, I said it right from the start of this class. My phone is, I think it should be less than 10% now. So, but no problem. I'll try to. Moreover, there will be the link to the video next. So you can also listen to it after the class. So I'll try to, I'll try to move. Okay. So what we mean by S block element is that when we write the electronic configuration, many of us should be familiar with that. We are still going to take it to electronic configuration like 1s2, 2s2. So elements in these groups, two groups, this group 1 and group 2, they will end in S. They will end in S, like hydrogen 1s1 because it has the atomic number of 1. So it will be 1s1. So it is an S block element. Beryllium has the atomic number of 4. It will be 1s2, 2s2. So that's 4. 2 plus 2, 4. So we have magnesium here. It has the atomic number of 12. It will be 1s2, that's 2. 2s2, that's 4. 3p6, that is 10. And 3, 1s2, that's 2. 2s2, that is 4. 2p6, that is 10. And 3s2, that's 4. It also stops at S. Don't be confused. We are still taking this itself. That's 1s2 electronic configuration. It's still a unit. The reason I'm not buttressing on it is that now it actually has some laws guiding it. We have three laws: the Hund's rule, the Pauline's exclusion principle, and the Gauss principle. So that's why I can't just rush into it. I would have explained it straight. So, but I'm expecting questions now. Please, any question from anyone for now? Any question or any observation?
Yes,
Sure, if you
I have
bring it
something
forward.
to say. I have something
Okay,
to say. This is the
all
person that
right.
is recording the this class. The person like made
Someone
the
is
video.
recording it.
I know the video is usually small, so we are not able to like see what you are doing. So the person make your highlights your
Okay,
you are the one sharing everything. So the person should highlight it so everybody can see it very well. But most of the time, the
okay,
talking you cannot see what the person
all
make
right.
very big so that we can actually see what it is.
Kingsmith, Kingsmith
Thank you.
has logged out. God. Okay,
Other than
okay.
that,
Kingsmith, do you hear what he said? He's talking about the video. I think you should be zooming the system.
if you finish,
I
you
understand.
not hold it. You cannot take on the system.
It is system. It is still the same thing. It's still the
Oh,
same thing, Mr. Lewu.
okay, no problem.
It's still the same thing. Yeah. So, Mr. Jeffrey, Jeffrey of
Okay,
Lagos.
you said something about the halogens and the group one element that they have opposite similarities. I wanted to understand that.
Okay. Why did you stop talking, Mr.
Did,
Jeffrey?
did you hear me?
No, no, I didn't hear you.
Okay, you said something about the group 7 elements, the halogens. You said that they have the opposite properties of group 1 elements. So I wanted to understand what you meant by that.
Group 1 elements are very, very strong metals. They are strong electropositive elements. While group 7 elements are very, very strong non-metals. Group 1 elements have one electron in their valence, one electron in their outermost shell. Group 7 elements have 7 electrons in their outermost shell. That means this one needs 7 to be complete, one to be complete. You understand? But this one doesn't want the 7. It's going to give the one out. So when the both of them jam, it is the best. When they say compatibility, that's why you see sodium chloride.
Okay,
It is
okay.
very
Yeah.
sodium chloride. Write it straight. NaCl, not Na2Cl1. Na1Cl. No, no, no. It's very fine. Common salt formula.
They
Something like
balance
that. That's what
themselves.
I mean.
They balance themselves.
Exactly. You know when you write aluminum oxide now, Al2O3, it doesn't. It's not even fine according to me. You know now, but
You have to start
to make it
balancing it
so,
differently.
that's the logic, sir. Any other question from anyone, please? This girl, this lady is raising her hand since. Miss Precious, what do you have to say? Miss Precious, what do you have to say? She kept raising her hand. Mr. Gabriel, please speak out.
Okay. What I want to say is, what do you call the group two elements? Sorry.
Group two elements. Abi,
Yeah, yeah, yeah.
did you say group two element? They are alkaline earth metals. Alkaline earth metals. Group two element. Alkaline earth metals. So alkaline earth metals are group two element.
Okay.
Group two, alkaline earth metals. No, 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 no. Not group seven. No. Group seven elements are called halogens. Mr. Ajayi. Group seven elements are called halogens. Halogens.
Yeah, so hello, can you hear me?
Yeah,
Hello,
I'm hearing you.
can you hear
Can
me?
you give me a few minutes to explain better? Can you give me a few minutes
Yeah,
to explain better? Just give me a few minutes, some seconds to explain better. Mr. Gabriel. The group seven elements, they are known as halogens. So group seven elements are known as halogens. Those ones that we call actinides and lactinides, they are inside the period 6 and 7. We have the normal element in group 7, in period 7, normal element. When counting this group 1 element, it will reach there. Group 2 element will reach there. So there is one space provided for them here. Are you saying my thing here? One space provided for them here. And the space is this. And the space is not going to affect the transition element. So after leaving the space now, they will now bring them out, come and arrange them. They will come and write actinium, this, rhodopodium, this, polonium, thorium, prolactinium, all of them like that. They are going to write them out. Uranium too is among them. So they are, what I'm saying in essence is that the actinides and the lanthanides, they are also known as the inner transition elements or the rare earth metals. Rare earth metals. Those are three names. Actinides and lactinides, inner transition elements, and rare earth metals. They call them these three names. So they are found in the group period 6 and period 7 of the group 3. Note that group 3 of the or let me say the first group of the transition element.
Yes, to
So they are
confirm
found in
that
the
too,
period 6 and 7.
you can check the periodic table. You see the atomic numbers. The atomic numbers fits in into that place, even though they are outside.
Uh, so thank you. So you can take a good look. That's why I say you guys should take a good look at it. I can't use the phone for the course material. On my system, I don't know what's wrong with it. Any other person? Any other question? I'm still
hello,
listening. I
sorry,
think so.
hello,
Yeah.
hello, can you hear me?
I can hear you.
What's wrong with you? Okay, so I was saying, for us to, as in, it's just like me digressing a bit, but for us to see more of like what you're showing us, what was on your screen, shouldn't we like get a whiteboard, or what do you think?
Oh, I don't get why, but
Yeah, I think that white boy is
Mm,
preferable because even with the note, I can't really see what he's writing down. You understand?
well,
Can
you
you
can go, you can go and get.
it's
I'm not
workable
using it
use
for.
your
now.
periodic table now? Use your periodic table for Facebook.
So what I
Just
did
because
was while he was
No
explaining
problem.
that
If I
thing,
if
I
it's
know,
for
went
us
I
to
went and
contribute,
got I went and
I'll
got
do
the
that,
picture of the periodic table and was looking at it and following through. So while he was
I don't.
doing the work on the paper, you can get the periodic table. The picture are full everywhere on Google and textbooks everywhere, and be looking at it. Even if he gets a whiteboard, the display of this Google video is tiny. Even if you pin his video, it will still be small. So I think while he's doing it, we can be
don't
doing
get
it
my
on our
Ali,
point.
phone
if this
too.
thing is
You don't
even
get my
clear,
point.
if
For
this thing is even
us
clear,
to have
this thing was doing is very clear. It's
listen,
still clear.
That's why we are doing it
so
together.
listen,
I'm hearing you.
at least it's legible. At least it's legible. At least it's legible, but it's workable though. That's what I'm saying. That's just what
It's
I'm
working.
saying. It's subject to review though.
Thank you, Kicksmith.
Yeah.
Mr. Gabriel,
Let's
Yes,
just
please. Let's
continue
talk about the
because
whiteboard in the WhatsApp. In the
begin.
WhatsApp, please. Let's talk about the whiteboard in the WhatsApp group.
Thank you, Kicksmith. Prodigy, Alpha.
Yeah, thank you. Just an observation. Can you please just, Abi, sorry, just, I want you to kindly help us to recap those group names, just the names alone, from group
Okay,
one
group one
to
is alkali
group 8.
metals without Ne, alkali metals or
Yeah.
alkali metals. Group
Okay.
two is alkaline earth metals, alkaline earth metals. Group three is the boron family, carbon family is group four. Group five is the nitrogen family. Group six is oxygen family. Group seven are known as the halogens. Group eight are known as the rare gases, noble gases, or stable gases. So the transition elements are the D block elements. We call them the transition metals. So and the actinides and the lanthanides are known as inner transition elements or rare earth metals. Rare earth metals. Rare earth metals. I come again. Group one is alkali metals. Group two is alkaline earth metals. Group three boron family, like that, their family. Till group seven halogens. So group eight is rare gases or noble gases or stable elements. While these D block elements are known as these transition metals. And the inner transition metal or the actinides and lanthanides or rare earth metals. Rare earth metals. Have I answered your question, please?
Sure, thank you.
Thank you. All right. Any other question on that? I'm thinking, if we want to enter electronic configuration, we just have to do it a little bit. Because I'm sorry, my time won't be because of the phone. My phone is very, very close to down now. Like almost any time from now. So my solar is in two and I'm using it to see this thing now. Yeah, I think if you want to see the periodic table, you are going to get it from that link that is dropped now. Okay, so let us know one thing or the other. I'm going to do a recap of what we've explained so far. Actually, it's more than a unit that we've explained. Absolutely about 2 units or something. Shall we just enter the electronic configuration? But we can't finish it because of my phone. Let me give a few introduction about it. So we mentioned the scientists and we mentioned their contributions. Everything is in the video here. We talked about the elements in the periodic table and we talked about Dmitry Mendeleev work. This is actually Dmitry Mendeleev's work. Group 3 to 8, just be calling them the family of the first member. Group 3 is the boron family. 4 is the carbon family. Group 5 is the nitrogen family. Group 6 is the oxygen family. Group 7 are known as the halogens. 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 And the group 8 are known as the rare earth metals, stable metals, or noble gases, because they are all gases. They have the helium, neon, argon, krypton, xenon, radon. That. So we have one thing we call electronic configuration. This electronic configuration is talking about the electrons. So, but in the next time we'll talk about it. I hope tomorrow my phone should be very full, and I hope to spend more time with you guys. So we'll be able to cover a lot. And after covering that a lot, we'll just enter past question. Perhaps we can take about 3 hours tomorrow. I hope my phone works well.
I think I've seen more of questions related to that electronic configuration in past questions. It's very important and it's a bit dicey, it's a bit difficult.
Don't worry. It sounds like that and it looks like that. I'm going to explain it in a way you understand it. Don't worry. You surely understand it. It's not difficult at all. Even the transition elements, electronic configuration. Trust me, we're going to take it. God will help us. So first thing is electron. We should know what an electron is. They said the atoms, we have different models on the atom. We have the first person that worked on this atom itself. That's J.J. Thomson. He said the atom is just a sphere that consists of the positive charges embedded with negative. So now that's negative electron. Another thing came, Bohr theory, which came to come and quantify that of what Rutherford's model of atom. So Rutherford model of atom, now it's the Rutherford planetary model of atom. He said the atom consists of a core nucleus that has most of its mass concentrated at the nucleus. This is the atom. To Sir Rutherford. Atom speed. The way the planet negatively charged and the neutron, which is chargeless.
Junction. Not that mountain of fire now.
The proton, which is positively charged.
Please mute yourselves now. Mute yourselves.
So Michael.
The proton is present at the center, so it's positive, and the neutron is also present at the center of the atom. That's chargeless. So now the both of them have masses. I think the proton has a mass of 1. kilograms, while the neutron has a mass of 1.673, just slightly different, a very slight difference between them. Okay, Andrew.
Sorry, what are you taking now? Like, what are you doing?
What do you say?
Yeah, I just need to understand it. Okay. Because
okay. I shall.
So you shouldn't enter what you won't finish.
Okay.
I know what I'm saying.
This might. I understand you, bro. I understand.
I suggest we should stop here because this one now entering is electronic configuration
Yes, and very broad, very, very broad.
Yes.
That's what I'm thinking, but I'm only trying to, for now, I'm not entering the electronic configuration anymore. I'm only trying to, I can't compare anything. Oh, you see only from, oh my God, what kind of appreciation is this? You don't understand anything since morning. That's good. You can just tap at the link, click on the link when it's time, and you listen again. God will help you. I wish you the best. You shouldn't have told me. You can just tell other people. I don't know what if you don't understand. Sorry. Okay, let's stop there then. I actually didn't intend to do the electronic configuration. I was only trying to introduce the electron. What we mean by the electron? That was Mr. Ajayi or Miss Ajayi. What do you have to say? Miss Ajayi, raise your hand, or Mr.
I understood everything, but when you started this thing, I think because of the network.
What do you say?
I said I understood everything you've been saying, but it's only when you started this thing you are drawing that I can't continue.
Don't scatter up their brain, yo.
Oh, sorry. I'm sorry, and I didn't even know you were the one. I didn't even know. No
Aloba,
problem.
please unmute your mic. Mute your mic, Aloba. Mute your mic.
Everyone, let's know something. Tomorrow, we should get prepared for it. I don't know. Maybe you should go and watch soap. Hello, well, share. Because we are going to cover a lot. I hope my phone works well and that there should be light or just get the flow. So that we'll be able to cover, we'll spend about 3 hours because we have exam. We're not just reading. We're reading for exam now, to be sincere with ourselves. We're doing this thing for exam. And if I actually want to help, I'll make sure I help. That's it. So please, let's try our best. Tomorrow, be prepared for it. Prepare your mind and your mental state tomorrow for this. Please, everyone. because we are going to cover a lot, a whole lot indeed. So let's please try our best to get prepared for this. So tomorrow we are going to cover a lot, and after that, we are going to treat past question in that tomorrow class. Don't be tired. It's because of yourselves. It's because of yourselves. I wish everyone the best. I wish everyone the best. May God help us all. And all our coming papers, I pray, amen.